Hello, algebra students. Mr. Lawrence here. If you happen to notice a video on the Mr. Jaybird 1970 site saying for Rumen, that's a friend of mine at church. He's a student at Root, and I made a little video for him. So you can just disregard it. You're welcome to watch it. It won't hurt you to watch it, but it's not in pace with our curriculum. So tell you what, if you ever see any videos like that say for Rumen, you feel free to just ignore them. All right, tonight's video, we're going to be talking about laws of exponents and dividing. Before we get to division, let's review really quick the laws of exponents for multiplying. So let's see here. I've got the quantity of 5x to the 6th times the quantity of 3x to the 8th. I'm going to multiply the 5 times the 3 and get 15. And then x to the 6th times x to the 8th. Well, how many x's are being multiplied? Wow, 14, aren't there? Yeah, there you go. Hopefully by now you're starting to realize that if you just, when multiplying, like bases, if you just add the exponents, you'll get the new exponent, right? Okay, now when we have a power raised to a power, it's a little bit different. Remember that this 2 means that there's 2 of these. So you could think about the problem this way, 4x cubed times 4x cubed, like that. Okay, now the problem is if this exponent is big, then you got to write a whole bunch of those out. I don't necessarily want to do that. I'm just going to square the 4. Notice I'm not distributing. This is not distribution, not distributing. No distribute, not distribution. But I will raise the 4 to the 2nd power and get 16. And then I'll do x cubed times x cubed, which would be x to the 6th. Okay, we'll check it out over here. The longer way, 4 times 4, oops, 16. X cubed times x cubed, x to the 6th. You get the same thing, don't you? Now, I don't know if you realize this, but if you take 3 times 2, you get 6. Yeah, let's do one more of those. So power raised to the power. Let's take 2. X to the, let's not use third. I just did third. Let's go a little stranger. Let's go with x to the 7th, y to the 5th, and z to the 8th. And let's raise it to the 5th power. Okay, you're getting good at this. You'll do 2 to the 5th, come up with 32. X to the 7th raised to the 5th. Well, that means there's 5 of these guys. So that'll be x to the 35th. Hey, 7 times 5, 35. For y, there will be 5 of these ones, and that will be y to the 25th. And then for z, 5 of these ladies here. Why am I calling them ladies? Because I called those ones guys before, just trying to balance things out. Z to the 40th power. Okay, so there you go. Now, the new lesson is actually to talk about division. Now, you know, Mr. Lawrence, I don't like the division symbol so much in algebra. I so much would rather use a fraction bar. And let me show you why. And we've talked about this a little bit before. I'm going to write 24x to the 8th over 8x to the 5th. All right. I'm going to think about 24 as 8 times 3. I'm going to think about 8 as 8 times 1. X to the 8th, I'm going to think about as x to the 5th times x cubed. And then down at the bottom, I'll have an x to the 5th. And if you want to put a times 1, you can. Don't put a times x, because that won't be x to the 5th anymore. All right, the 8s are going to cancel. The x to the 5ths are going to cancel. And sure enough, I'm going to have 3 times x cubed. That'll be over 1 times 1, or better yet, just 3x cubed. Pretty easy. Hey, look at that. My exponent is 3. 8 and 5, and my exponent was 3. Interesting. All right, let's take a look at this one here. Let's rewrite it. 35 x to the 10th, y to the 6th, over 50 x to the 8th, y. How can I think about this? I think I'm going to think about 35 as 5 times 7. Think about 50 as 5 times 10. x to the 10th I'm going to think about as x to the 8th times x squared. And the y to the 6th I'm going to think about as y to the 6th. Oops, my mistake. I'm going to think about it as y to the 5th over y. Now I'll look for my simplifying. 5's will cancel. X to the 8th will cancel. Oh, did I forget to write a y there? I sure did. And then here, my y's will cancel. So what's left? Well, in the numerator, it looks like I have a 7, an x squared, and a y to the 5th. In the denominator, I simply have a 10. And there you go. Hey, wait a minute here. Wait a minute. The x ended up being an x squared, right? X squared. And look, I've got a 10 and an 8. Very interesting. And I got a 6 there for the exponent and a 1 on the y. Look at that. I ended up with a 5. Do you see it yet? Do you? All right, let's try another one. And then we're going to wrap this video up. I'm going to have a 16x cubed y to the 5th. I'm going to put that over a 20x to the 1st y cubed. Think about 16 as 4 times 4. I'm going to think about x cubed as x to the 1st times x squared. Y to the 5th I'm going to think about as a y cubed times a y squared. All right, the denominator, 4 times 5 is the same as 20. There's an x to the 1st, and there's also a y cubed. And so what's going to happen? The 4's will cancel out, the x to the 1st will cancel, and the y cubes will cancel, leaving me with a numerator of 4x squared, y squared, and a denominator of 5. Now, it won't always be the case that the denominator will be like that. We'll talk more about that in the next couple of days. All right, so let's recap. If we're multiplying like bases, like, for example, x to the 8th times x to the 5th. That's going to equal x to the 13th, right? If we're multiplying like bases, we add the exponents. And it doesn't matter if it's a big kind of ugly problem, like if I have x to the 5th, y to the 4th, z to the 2nd, and I'm multiplying that by x to the 3rd, y to the 11th, z to the, 5th. Okay, well, x to the 8th, right? Y to the 15th, and z to the 7th. Pretty easy stuff. Okay, and then we found out when we have powers raised to powers. We have powers raised to powers. When we do powers raised to powers, that's a situation like, say, 5x to the 4th y squared, and we're going to cube that. All right, well, first of all, the 5 cubed is 125, right? But the variables are simple. X to the 12th, y to the 6th. 4 times 3 is 12. 2 times 3 is 6. Then we found out when we're dividing like bases, well, in that case, we subtract the exponents. So if I have 20 x to the 25th, y to the 11th, and I'm going to divide it by 10 x to the 15th, y to the 4th. Well, I like to rewrite it as a fraction, Okay, but I'm not going to go through the whole process here. I'll rewrite it. X to the 15th, y to the 4th. We're going to end up with a 2 in the numerator, x to the 10th in the numerator, a y to the 7th. That'll be over 1, and so better yet, it'll just end up being 2x to the 10th, y to the 7th. And if you notice, we had a 25 and a 15, and we ended up with 10. 25 minus 15 is 10. 25 minus 15 is 10. And of course, very similarly, we have an 11 and a 4, and 11 minus 4 is 7. All right, that's it for the video, Mr. Lawrence.